All right. So our agenda here for everyone to see. We're going to go over a brief intro, then go into the six core capabilities an MSSP should be able to help you with. Go over the reviews at the end, and we can do some chat prompted questions, I believe.
Yep.
Yep. Yep.
All right. So AI is adding some new things that we have to monitor and new places that threat actors can try and get in and cause trouble for us. Model endpoints, if someone's trying to run a local instance of their favorite model, or if they've got it connected to an API because they're an admin or someone trusted enough to have that access, they can generate a token and give it to a model, and we need to monitor that as well. Training pipelines need to make sure that good information in, good information out, and shadow IT. If you don't let them use the models they want to use, they're going to use it anyways. So how do you look for that? Tools that we have right now can help, but they don't help with everything because these large language models go off of natural language like English and not structured query languages um, like SQL. it You can't just do set and forget. There's going to be more work that everyone's going to have to do in the space to secure things. Um, the things that we need to protect that are at risk of being compromised are data, client data, customer data, uh, compliance related data, PHI, PII, company secrets, just customer trust, the big one. You don't want to lose any of that. So we took a little poll, asked the community, hey, what's your biggest blind spot that you are aware of right now? And the majority of you shared that visibility into AI risk. And visibility requires setting up stuff to be able to monitor and detect and respond to incidents. If you're not looking for it, if not watching it, you can't protect it. That's why shadow IT is the bane of all of our existence. Um, and then from SailPoint, they shared a survey where 80% of organizations reported AI agents performing unauthorized actions. There have been some reported cases where employees have gone to places like Fiverr or TaskRabbit and downloaded models to do their work for them. Um, that's one example of many. So, how do we detect this stuff? Yeah. So we'll go over the six main points: AI-specific penetration testing, secure AI DevOps and CI/CD pipelines, adversarial model evaluation, cloud and infrastructure security for AI, AI-aware threat detection monitoring, AI-aware incident response and recovery. And as we go through these slides, each of us, three panelists, will kind of start the conversation, and the other panelists will also share additional insights if we have time. And the first one, AI-specific penetration testing, I believe, Arvind, I'll let
Yeah.
you go with that one.
Yeah, so I think there was a data point like one or two slides ago that said something about, at least 80% of the attacks that's on AI systems has something to do with, weaknesses in access control. So we're seeing that a lot in practice when we're out there doing pen testing of these AI applications that are getting built and launched. What we're seeing is that the strength and resilience of the AI implementation is only as good as the strength of the AppSec controls that's built into the applications that the AI is getting embedded into. Because most AI out there is being built into existing web applications and APIs, and it borrows from those applications basic AppSec controls like IAM, authorization checks and access control checks, data security controls, and so on and so forth, right? Now, companies are out there building and launching all kinds of AI, right? And it comes in different use cases and form factors, right? Internal use, external use for their customers and consumers, everything from chatbots to agentic workflows to third-party integrations with data sources like SharePoint to pull data into a RAG and so on and so forth. Um, Most companies that are building AI applications right now are also relying on a foundational model provider, right? So the biggest thing that customers are concerned about is a risk associated with data leak, right? Data leaking into those model providers, or just sensitive data, to Jonathan's point, getting leaked across tenants and across customers. Now, customers that are building SaaS applications that have an AI capability in them, they might be out there touting that they have a zero data retention policy agreement with model providers like OpenAI and Anthropic. But is that enough, right? RAG makes it more complicated when, as a company, you're applying your own data set on top of the capabilities that your LLM provider offers to you, which means you're kind of on the hook to perform access control checks on all the data that you're retrieving from the database before you send it upstream through an LLM call. Agentic architectures make it even more complex because the AI might be out there talking to all kinds of internal and external applications and tools via APIs and MCP layers that might be broken and insecure to begin with. So the natural question is, what are you doing about it, right? Are you pen testing your AI apps and software before you launch them out in production? Are you testing your prompts to see if you can trick the AI into leaking sensitive data? Are you testing your prompts to see if you can get it to do things that's outside of the scope of the instructions that you gave it in the first place? Now, sure, there's guardrails, and developers are starting to use guardrails that are built into things like Azure AI and AWS Bedrock. But the guardrails as a concept and as a technology principle are relatively new, and they can be bypassed with enough time. Um, can you test the AI to see if you can inject malicious content, let's say malware, into PDF files and other kinds of files that you might be uploading as a data source into the AI as part of RAG implementations? The other part of it is, not just looking for security weaknesses like data leakage, but we've had some customers that have come to us and say, hey, I'm building a SaaS-based tax filing application and I've got an AI copilot out there helping consumers file their taxes. We don't want the copilot out there suggesting things that could basically lead to the consumer conducting tax fraud, right? Because that would just cause serious reputation harm. And can you test for those kinds of misuse and abuse cases, right? Not just regular security threat vectors. So the big takeaway here is test your AI often. Testing it repeatedly is kind of becoming a big thing too, because by design, AI models tend to be stochastic and random, which means that the same prompt sent twice, thrice at different points in time might actually create different responses and see different behaviors back from the LLM. And so testing it once as a point in time assessment is not enough anymore. You're going to have to keep hacking away at it consistently. A lot of it, because of that, is also trial and error. So an AI pen test typically means that it's a manual, time-consuming trial and error type exercise. So that becomes a problem. So how do you do that at scale in a repeated manner? So I think customers are starting to now think about, yes, I want to test, but I also want to test smart because every pen test program out there on the planet has a limited budget in terms of time and cost that they have to stick to. So how do you test smart with an awareness of the type of guardrails that are built into the applications, as opposed to just testing one prompt at a time, right? So those are the big takeaways from this slide where we're focused on pen testing. Now, on the next one, it's beyond just testing the AI that you're building and launching, but it's also about how do you secure the production process, right? How do you secure the process by which you're shipping out AI software to the field? Often, the process that you're using to build and deploy AI software is not that different from the process that you might already be using from a CI/CD perspective for regular software. So, your typical traditional AppSec secure development and secure SDLC controls matter here, right? And they still apply just like they have for the last decade and a half. Um, Things like static analysis and code reviews. Are you doing code review of all the code that might now happen to be talking to an AI LLM provider? Are you looking at source code, but also infrastructure as code for exposed secrets, like OpenAI tokens, for instance? Are you studying your source code to see how your developers might be doing things like data masking and authorization checks while they're retrieving data from a database to send up to an LLM? But it's more than code. It's also about, all of these applications are obviously containerized and they're cloud deployed. And so what are you doing to review the configuration of those Docker images, how are you hardening those images, right, before you send them upstream? The other big aspect of it is it's not just about the process of securing the process with which you're building and launching AI software, but what about the process with which your developers might be using AI to build software? Claude Code is now the rage. Everybody that's a developer is out there using Claude Code to write code. What are you doing to evaluate that code? What are you doing to identify and fingerprint which parts of your code base came from an AI as opposed to a human? How do you track and report provenance against your software bill of materials to include AI generated code? But also, are you doing code reviews of the code that's generated by the AI? And within that construct, there's obviously the philosophical debate of is AI generated code somehow more broken than human generated code, or is it better? Or is it broken now, and as the models mature over time, they get more secure by default over time? Um, Jonathan made a comment earlier. If you let people use AI, they'll use all kinds of AI, right? So, what kind of governance mechanisms have you put in place to make sure there's an approved list of models and libraries and frameworks that your developers are allowed to use? And what kind of training and guidance are you providing to your developers on how to use AI responsibly? So, think of this sort of slide as we're focusing on a process to build AI software, but we're also focusing on a process to use AI to build software securely. Now, in the next one, we talked a little bit about pen testing, but I was primarily focused on testing the application that might be interacting with an AI. What about directly testing the model? What about testing the data set to see if you can poison the data set? Jonathan, do you want to chime in?
Yeah. And as you had previously mentioned, when you prompt a model, get different results, or hopefully you'll get multiple different results instead of the same result every time. And that's part of avoiding an adversarial model evaluation where they'll provide a prompt, try and get a response from the model, and by distilling that information, they can generate a copycat model of what you have, what you've spent time and money and resources to develop yourself. So, helping to detect rapid queries and responses through the API or through some sort of programmatic method is something that you would want to be able to monitor because they may be trying to steal your lunch. They may be trying to benefit off of all your work. OpenAI has alleged um, DeepSeek of distilling through this same process. They're not the only one. They're not the only ones who have been accused of doing distillation attacks like this or distillation of models like that. But you can imagine how if you spent a lot of time and money getting your model to work for healthcare, for taxes, for a specialized industry, you don't want someone else benefiting without paying you license fees or what have you. Um, Reverse engineering your logic by interacting with the model. There's also the possibility of poisoning your agent or your model, depending on the size of the parameters that you're running. Maybe you're trying to run a local model and you don't have big expensive GPUs with 32 gigabytes of VRAM. Maybe you've just got NVIDIA 1080 from back in the day, and maybe all you can run is a 600 million parameter model. Or maybe you've got something more consumer focused where it's maybe 16 gigabyte VRAM, and you're able to run up to 13 billion parameters. Those can be poisoned relatively easily. Anthropic found out or shared uh, just 250 malicious documents, and they could potentially poison, backdoor, mess up your model, and it only takes a few bad eggs to spoil the carton, right? Or a few bad apples to ruin the basket, the cart. Um, so yeah, you got to be careful with the models you already have that you've decided you do want to have, that you do want to host, that you do want to work on. And then if you want to run these on the cloud instead of locally, you need to make sure that your cloud is configured properly to secure all that stuff too. Uh, Big pain point all the time is containers. Whatever is installed in that container, like Netcat or PowerShell, the model could be manipulated into using those against you. So whatever tools you give it, be prepared for it to possibly be used against you. Can you detect it? Can you defend against it? Does it even need that? If it doesn't need it, get rid of it. Make it as streamlined and Spartan as possible. Um, Identity access management. If you are seeing ClaudeBot uh, from this container trying to access the main database and upload files to it or do something it's not supposed to do, change, delete, RMRF, the database should have the access to do that via IAM. Probably not, and I presume you've heard of those horror stories of Claude or Copilot or some model just randomly deciding to delete production servers with RMRF because, oops, you're right, I shouldn't have done that. Well, if you use identity access management or put in guardrails to prevent the bot from even having the permissions to do that, you could probably save yourself a lot of pain and suffering. Um, your cloud posture for running AIs, are you monitoring your API traffic coming through DLP? Microsoft had initially entrusted environments to enable DLP for Copilot on their own, which wasn't all that great. And so now Microsoft by default has tracking in DLP for Claude API, Copilot API traffic. But if you're not running just Copilot, you're running other APIs through your DLP. Are they included? Are they being monitored? Are they being tracked through there? Check. You don't assume. Um, and you still got to monitor the network. Who is trying to connect to your model? Who is trying to connect to your cloud infrastructure? If you are just a healthcare service based in Tennessee and nobody outside of Tennessee is being served by you, you could probably safely assume that you can geo-block Canada, Russia, China, South Africa, wherever people shouldn't be accessing your services from. And that way you can reduce the ability of them being possible threat actors, being able to attack you at all. If you block it from even starting, you head off the headache early on. Um, so with that, I mentioned DLP a little bit and how we need to track and monitor things. I'll let Doug go into the next two slides.
Cool. Cool. Um, One of the things I want to kind of point out, back on the first slide, we had the results of a poll that we took. And 51% of the respondents had mentioned that visibility of the risks associated with AI was their biggest concern, one of their biggest roadblocks. Um, and then we started talking about the pen testing aspect, and we talked about the adversarial simulation and really focusing in on how we protect our models and our infrastructure, both for on-premise and within cloud infrastructure. And there is a resounding and there's a consistent topic in each one of those. Visibility, right? So being able to see what's going on with your models and your infrastructure and your code, your CI/CD pipeline, anything that's associated with your identity store, do those automations, are they acting within the constructs of what you have established as far as what should they be able to do? Should they be able to go in and modify code? Should they be able to go in and actually delete delete the guardrails? There was an article that I had seen probably 2 or 3 months ago, about where OpenAI had actually witnessed their AI trying to remove its guardrails because it wanted to continue to learn, wanted to expand beyond the boundaries of what they had established. Um, One of the key aspects of this is that traditionally we used to look at things like telemetry that would come from EDR, from event logs, and those are great, right? Those kind of tell us after the effect, after there has been compromise or exploitation of weaknesses within different AI systems, and so we kind of have to expand where we're looking. We have to dig a little bit deeper. We have to dig into those CI/CD pipelines to make sure that they are operating within the bounds that we establish. We have to make sure that data inputs are within constraints of sanitization aspects, and we have to alert on those. We we generally, from detection perspective, we every organization relies heavily on the out of the box detections. And if you buy a SIM, whether if it's CrowdStrike, Falcon Complete with their next gen SIM, or if it's Sentinel-1 AI SIM, um, all these different SIM platforms and SOAR platforms have a lot of really good detections out of the box for what we used to do. Um, None of them are for the AI generation. And so that's where we have to, in each scenario, you have to look at um, what does your pipeline look like? How does your automation pipeline work? Um, where are you monitoring for inputs? Where are interactions coming from? And you have to build out and make sure that visibility of that information is coming into your monitoring, and that the policies and the constructs of those are well defined, so then detection capabilities can be built around your infrastructure. Um, so that's, I mean, monitoring changes. It's still the same thing. You have to be able to see what you want to monitor. If you're not seeing it, then you can't monitor it. And I think that was kind of one of the things that we had in our poll, right? Is you can't monitor what you can't see. So we do, for customers that have very unique situations that are outliers from normal environments, that what we consider normal environments, right? Is that we work with our customers to, excuse me, to walk through what policies do they have in place around their infrastructure, and um, work with them to build out that custom detection capability. Take a look at do you have good visibility in your CI/CD pipelines? Do you have good visibility in your cloud your cloud infrastructure and workloads and stuff? Um, so all the detection in the world, we could put all that in. We could put a lot of proactive protection controls in, to do as much prevention as possible. Um, an incident happens, it becomes a different game than what we normally follow, right? Um, if Think about it, the traditional incident response process is that there's the detection, containment, eradication, recovery, um, lessons learned lessons learned model. That detect and containment, is it's a game changer when it comes to AI. You think about it, if you have an event that's basically compromised your Active Directory or your identity store that's on premise, so you shut off the internet connection, that severs the connection from the threat actor. With threats like poisoning of AI models, that that threat that has caused the incident in the first place is still living and breathing in that environment. So that segmentation from public access and from external access doesn't necessarily bring containment in. There has to be analysis, right, of, how is the LLM interacting, and, is there are there trace behaviors that is indicating where the problem is? Because you obviously don't want to just, power off, right? Power off, that, yeah, sure, that's containment, but that's not the step towards restoration of operation through the recovery phase. One of the things that, kind of stepping back to detection, because this is a game changer, the pen testing and the security testing against LLMs and APIs, AI infrastructure and systems, those are great indicators to really develop out those detection capabilities. It's also great indicators for establishing how you would modify, or, put some use cases within your incident response plan to address, AI compromises and events that would, impact, AI. And we have a cool blurb on here that's from Palo Alto. AI assisted attacks, right? The exfiltration is 25 minutes versus 2 days in traditional attacks, right? 100 times faster. Um, I suspect over time, and as we continue to progress down the path of AI adoption and proliferation of AI services across many different verticals, that time to exfiltration and that time to compromise, is going to shrink. It's going to get to where it's 10 minutes. So we have to be able to position ourselves, um, from a security industry perspective, of getting to detection faster and being able to respond quickly. And some of that, guess what? We have to rely on AI itself to be able to do that. We have to train our own detection and response models to be able to look at, what's happening within those environments, and be able to respond and give us that information that we need, in very short time. Um, all of that is great, but there is a human loop that should always be there in AI, especially when we're talking about, responding to AI, compromise incidents and events, right? So, um, we work with our customers to expand out tabletop exercises. We touch on many different topics, right? Many years, probably the last decade, we've focused a lot on things like ransomware and phishing and everything else. Now it's time for everybody to start expanding their tabletop exercise playbooks to include AI. Um, so I kind of touched on where the pen testing aspect. It really is the starting point for protecting AI systems. That gives us, from a security perspective, and especially on the blue team side of things, right? Arvin lives on the attacker side. I'm on the blue team side, but we're still good friends about it, right? Um, the adversarial activity that red team can bring to the table, and continuously testing and assessing against those systems, helps build out a library for detection capabilities and also for response capabilities. Um, that it helps prove out being able to see what we need to see. One of the themes, that I always go with is you can't monitor and protect what you don't see. Um, by engaging in purple team type activities where there's a red cell and a blue cell, um, that they're able to bring that together. Hey, here's the activity. We should be able to see this activity. And it's very prescriptive at that point. And then you have a very quick list of identifying where you have gaps. You can get those gaps closed pretty quickly and get detections in place. So that's kind of why, the MSSP with offensive security, it helps bring together a stronger AI position and protection.
It's easier for me to write a detection for activity if I actually have logs that are ingested that I can look at and see, oh, okay, that's how the red team did that thing. We did the detection go off, or did it completely miss it, or did they do something completely new that I have to write a new detection for? Which
Yeah, yeah,
I like that. But that means I get extra work to do, but that's why we work together. I can ask Arvind and the red team side, hey, how'd you do that? Or um, what were you looking for when you did that? Or how would you help me, the blue side, to defend against stuff that you guys were doing? And
yeah.
that's
And even in controlled testing, you can ask red team to actually introduce poisoning, um, and then follow that poisoning through all the steps. How does how does it impacting the rest of the model and everything? And I'm sure, if I went to Arvin and said, "Hey, can you poison this model?" He'd probably rub his hands together and give a sinister grin and say, "Yes, we've been waiting for this opportunity." Um,
Yeah, a lot of this is also kind of going back to the point that I made about budget, because customers are obviously working with the finite amount of money and time that they can spend. Pen testing only takes you so far, right? And it's
right.
typically a time-bound activity. You're doing it once a year, doing it twice a year. Most of our customers are playing whack-a-mole with all the AI that's creeping up on them that needs testing. So then how do you go from there, dovetail into defense, so you're consistently monitoring for those kinds of patterns? You're looking for anomalous behavior, you're looking for weirdness in prompts, you're looking for data leaks and so on and so forth, right? So this is truly where the defense kind of augments the offensive, where the
Mhm.
offensive gets blocked off on budget.
yep.
Yeah,
And if
and
we
the two
know,
together is better, right?
Yeah.
yeah, and if we know that we already have detections that are working very well for these use cases, we can inform red team, hey, we're covered over here. Go crazy over here. And so that's how that feedback loop helps to save customers time and save us time. We also have a security checklist that you can download from an ebook that we have that we released recently. You can take this back with you, an action item, and go back to your team and go over this, try and get an idea of where do you stand. Um, are you actually pretty well covered and that you didn't know that other department was covering this thing? Or you can also hopefully find out everyone assumed you were doing it. Oh, we're not. So this is where we need to maybe put some budget in for next year, or depending on how severe it is right now, to get this thing covered that everyone thought that we were covering. Um, yeah, please feel free to download that, review that, and use that to help you and your team with as we all learn as we go with all these new capabilities that these models provide.
I think just to round off your mention on the checklist, the checklist, I think the way I look at it is that it's a good opportunity for everybody to look at how well-rounded their security program is and how much money and time they're spending on the defensive side versus offensive side. So to round up the six capabilities and to make sure that you're doing some testing, but you're also doing some runtime and real-time monitoring. But to Doug's point, you also have a plan of how you're going to respond to incidents. And to Jonathan's point, how are you securing the pipeline and the process and the cloud infra and the containerization of it? It's all kind of important when you can't just stop with one and not do the others. So that's the whole point of this is a set of six, maybe it needs to be a set of 10 later. This whole space is evolving quick. So how do you stay up with all the moving parts in this, and how are you doing enough in each of those buckets so that you're building a scalable program?
Yep.
And test your plan and
Yeah.
test it again. And anytime that you have a change, um, it's always good to run through your tests as well. A change in your APIs, code changes in your APIs. I've always lived by the rule that when there is a significant enough change in how code is written or deployed, that it's always good to test that again before you put it into production and trust it. And generally pen tests, and any vulnerability testing, and weakness testing, it's a point in time. And with AI changing so rapidly, that point in time passes very quickly.
Yeah. And making sure that all the folks in the incident response plan are actually aware where it exists, where it lives. So when an incident happens, they know where to go. You don't want to be the service desk person who gets a random call for something that sounds benign or is very obviously not good. But if I'm the service desk person and I don't know where the incident response plan or what I'm supposed to do, I'm going to wing it and I'm going to do the best I can, even though you and your organization spent a lot of time and money to have this document. If I don't know where it is, if I don't know how to access it, if I don't even have permissions to access it as the service desk person, just kind of all is for nothing until someone else higher in the chain gets the knowledge, the director, the CISO, when they finally learn about what's been going on, that the service desk person's been trying to the man behind the curtain just keep everything going. It may be more damage can be done than probably should have been done if the service desk person just knew where to look or where to go or who to escalate to or who to notify as soon as they heard of the thing. Um,
Um, I think we're at a point where we want to open it up for questions. I don't know if we have any questions yet.
Doesn't look like we have any yet.
Okay.
And wait a minute for them to come in.
Well,
All right. Oh,
maybe.
we have a question in the chat. You can unmute if you want.
Darcy?
Darcy.
Hi, this is Darshi. Do you recommend any open source pen test tools for us to run them before, to just know where we stand, what is it before, we come across to some professionals?
Yeah, the problem with testing prompts, like I said, is that it's a little bit of a manual trial and error process. Now, there's AI-backed tools that are coming up to test the AI, but they're not necessarily all that trustworthy yet, right? So it's not quite at a level of maturity that you can point and shoot at AI applications and let the AI assess another AI. We're not quite there yet. Those are coming up a lot, and there's vendors out there trying to sell that kind of software because like for example, I'd mentioned that the AI is random in the way it behaves, and so you kind of need to continuously red team these applications. And there's a limit to how much you can test manually in a time boxed week or too long, a 2 week long pen test, right? So, are there open source tools? There's some tools, but you get what you pay for, right, so to speak. I think the most important thing with pen testing is to be smart about it, right? Not to necessarily use automation or free tools. If you're aware of what kind of guardrails are being used in the application and how your developers have configured those guardrails, then you can do a very targeted and focused test to see if you can bypass those guardrails. If not, you're kind of like groping in the dark, right? You're shooting dots and you don't really know what you're testing for. Also, understanding the context of how the AI application is being used by the end users and what could go wrong means that you can come up with very specific and focused test cases to go test for, as opposed to just looking for genetic things like a prompt injection, right? Where it's a very manual trial and error type a process that takes a while.
Okay.
I think from an automation standpoint, more than open source pen testing tools, I would say look at static analysis tools because all static analysis tools are now getting better at catching weaknesses in the AI implementation, right? Looking for access control failures, data leakage, sensitive data exposure, like secrets in code, that kind of thing, right? Those things become important. Um, None of these tools, whether static or dynamic, are going to help you catch like the real business logic issues, which is what you're going to find when you're putting a human on a pen test to go test prompts, right, manually. So, like the tax filing example that I'd mentioned earlier, where you don't want the co-pilot out there helping an end user conduct tax fraud. That's really hard to automate the testing of. Your pen test tools could look for basic things like your OWASP top 10 around LLM, so basic prompt injection and things like that. It can try to fuzz against your LLM endpoints and APIs to see if it can get it to do weird stuff like leak system prompts and system data, but that's about where it's going to go.
All right, do we have any other questions? All right, doesn't look like we have anything else.
Okay.
All right, sounds good.
Well, thank you very much, everyone, for choosing to spend some of your time with us. And thank you, Arvind, Doug, everyone who helped make this possible. And maybe we'll see you all again at another webinar in the future.
Yeah, thank you.
Thank you.